Let's do some more factoring. We've looked at factoring something with two terms. That was perfect squares in each of those terms and a minus sign in between. We called that the difference of squares. I'd like to focus on factoring something with two terms again, but it's going to be perfect cubes instead of perfect squares. And it can be the sum or it can be the difference of. So the focus here is factoring the sum and difference of cubes. I'm going to come to this in a minute. These two formulas need to be memorized if you're going to be able to factor a sum or difference of cubes. Let's come over here to the left for a minute. Mathematicians saw this binomial, a plus b, times this first term squared minus those two values, their product, plus this last term squared. They found it to be, when they multiplied by distributing, so this a times a squared is a cubed, and a times a minus ab is a minus a squared b, and then finally a times b squared is ab squared. And then of course they had to take b times a squared, b times a squared, positive. I'm going to put it right underneath here because it's a like term, b times a squared. And then right here, a minus, this positive times this minus is an ab squared. So it's a minus ab squared. And then finally, the last terms multiplied together, a positive b times a positive b is a positive b to the third power. And when they collected their like terms, it ended up that all they had left was a cubed. Those added to be 0. Those added to be 0. And then in the very end over here, b cubed. So the product of this binomial times this trinomial always gives you what's called the sum of cubes. These are both cubes. A is cubed, b is cubed. So here it is again, just written again. It says that whenever you have an a value cubed plus a b value cubed, it'll always factor into this binomial times this trinomial. And likewise, I could show you this, but I'm not going to take the time, that if you multiply this times this, you get that statement as well. Could I ask you to notice a couple of things? The binomials look alike, but this one right here, the binomial has the same sign, and this one right here, the binomial has the same sign. I'm going to say that those signs match one another. So I'm kind of pointing to this one and that they, maybe I shouldn't put those arrows there, that they match their given problem. So this sign matches that sign. This sign right here is always opposite. I don't know if I can spell that out and have enough space here, but this sign is opposite of that one. Look at this plus sign. It's opposite of that one. And these two signs are always positive. So could I ask you to remember that as you memorize this, that this sign matches, this one's the opposite, this one's positive, and we often spell the word mop that you clean a floor with, M-O-P, matches, opposite, positive. Right here, look, matches, opposite, positive. So that's going to be a help for you to factor a problem. Now let's go ahead and I'm going to leave this up here. Let's do an actual problem. And it's going to be, we're going to do a sum of cubes. So first of all, this is what one might look like. X cubed, that's easy to see that that's a perfect cube. 64, that's a perfect cube. If you have a graphing calculator, you could hit I'm pretty sure it's the math key, and about the fourth or fifth item down is a button you could hit to find the cubed root of 64. That's what you need to find out. I'm just going to jot this down and then I'm going to erase it. The cubed root of 64 is the number 4. That's the value that you would cube to get the number 64. So that's how, when working with numbers, you find out what value is your A value to go in here and your B value to go in here. So I'm going to come off here and I'm going to say my A value in this problem is X, because I would take the letter X and cube it to get that statement. And my B value in this problem is the number 4, because I would take the number 4 and cube it to get 64. And then I would take this X and this 4 And I would put it in right here. I'd put in an x plus 4, and then an x squared minus x times 4 plus 4 squared. So keep that formula over there in mind. It is, a plus b times a squared minus ab plus b squared. So I'm just recopying it. And so right here, I'm going to put in my x value. Right here, for b, I found out that that's 4. And in factored form, this right here, the binomial will be x plus 4. I'm going to put in this a value again and square it. Then the a value again times the b value, which is 4. And then finally, my b value is 4 in this problem. My b value is 4, and I'm going to square it. And this trinomial needs to be cleaned up, and it needs to look like this. X squared minus 4x plus 16 times this binomial of x plus 4. And if you would multiply that all out, you would get x cubed plus 64. Let's do one more. So let's do a difference of cubes. And I might write this one right down here in a minute. I'm going to give you a second to catch up with me. I'll get rid of this. Get rid of my original problem. The problem we're going to look at is going to be y cubed minus 8. And so, when it's a letter, the first term is a letter, I got to look for what letter, y, if I raised it to the third power, would give me y cubed. And then what number, 2, because if I raised it to the third power, I would get that 8. Or you could find the cube root of 8 on your calculator. And you come over here then, and you'd put in for a and b, you'd put in, right here, you'd put in the y. This is always a minus sign for a difference of cubed. So y minus 2. This is my a value. I always kind of look over there. I'll take that and square it. My a value is squared. Always a plus sign. Ignore this minus sign. Don't think of that as a negative 2. My a value is y, my b value is 2. And now I want a times b. So y times 2. Or how about 2 times y? And then I want my b value over there, way over there. My b value is 2. And 2 squared is the number 4. So finally, the factored form of this, it was a difference of cubes, is this y minus 2 times this y squared plus 2y plus 4. There's the factored form of y cubed minus 8, because it was the difference of cubes. Let's stop. We'll get a little bit more challenging ones in the next video clip.
First one I'm going to do here is 64x cubed plus 125, and then we've got 27y cubed minus 8. So let me see if I can bring my formula back in here real quick. Okay, so it looks like in this one we'll have to use the bottom formula. Okay, so it looks like we have something cubed plus something cubed, but the first thing I'm going to do is I'm going to just rewrite it a little bit. Okay, so I'm going to rewrite my 64x cubed. And what I'm going to do is I want to write that as something cubed plus something else cubed. Okay, that's kind of how I'm interpreting this first or the second formula. Something cubed plus something cubed. Well, I guess to get 64 we would need 4 cubed. And to get x cubed, we would just need to stick an x in there. Likewise, to get 125, we would need 5 cubed. So now I'm going to use this formula. So instead of just x and y, I've got 4x, and I've got a positive 5. So instead of x, I've got 4x, and then it just says, right, plus whatever's in the second set of parentheses. And then it says, whatever was in the first set of parentheses, it says now take that thing and square it. So I'm taking my 4x and I'm squaring it. Then it says write a minus sign. It says take the first thing times the second one. So 4x times 5. And then it says write a plus, and it says whatever number was being originally cubed, it says now we take that number and we square it. So certainly a little, I think it takes a little getting used to for sure. If we simplify this, we have 4x plus 5 in the front, not much to do there. And I'm going to take 4x and square it, so 4x times 4x would be 16x squared. We have negative 4x times 5. Well, I can multiply the negative 4 and the 5 and make that negative 20x. And then our positive 5 squared will just get positive 25. Okay? So one more here. I'm going to do the same thing. I have something cubed minus something. Well, okay, so the trick is we have to, again, kind of rewrite them both. So I think what number cubed would give me 27, and there we would just need a 3. And to get the y cubed, we would need a y in the parentheses. Minus, and now I think what number cubed is 8. Well, excuse me, I wrote a 2. I'm getting ahead of myself. So I think 2 cubed is going to give us positive 8. And now we just do the same thing. We just use our little formula here. Okay, so don't get confused by the x and the y here and the fact that we have y's and numbers. To me, we're using this formula, and it says if you have something cubed minus something cubed, it says whatever was being cubed, so kind of whatever's downstairs, write that first. So we'll get a 3y. Then it says write a minus sign, and it says whatever was also being cubed, it says just stick that next to it. So we'll just drop our positive 2 down. And then it says take the first thing in the first set of parentheses and square it. Then write a plus, and now multiply the things inside the parentheses together. So 3y times 2. And then it says whatever number was out there, it says we just square that as well. Okay, so if we simplify this, we'll get 3y minus 2. 3y times 3y will give us 9y squared. 3y times 2 will give us positive 6y. And then 2 squared will give us a positive 4. And again, we have now factored 27y cubed minus 8.